Hey, this is Team Kenai here, and we are going to demonstrate our VOR radar here today for our final project. And just to begin, we will start with our. I'm going to discuss the testing strategies and techniques we use for our project. So, basically, we have two classes, excluding the J unit. We have a final VOR GUI. This is going to be the GUI for our radar, and then we have a class called VOR receiver, which is going to be doing the calculations for the radar. And then the next step is going to be our the functionality of the system, or for the actual testing. The VOR receiver, our team member Gerald was responsible for the making the calculations, and Adrian helped him out as well. He used JUnit to make sure all of the calculations were correct and there were no bugs or problems with it, and he did a great job. For the GUI, there was really no JUnit testing that could have been done for it, so we did random testings in order to make sure it was adjusting to the appropriate coordinates for the GUI. Moving on to the functionality of the system. Before we get to that, actually, I'm sorry. Our total line of code, we have 419 for the GUI, 771 for the calculations. The JUnit, we have roughly 1,080. And for the amount of hours per person, it was roughly around 40 hours per person, combined together, made to about 120, maybe 130 hours per person for this project. And then now Adrian here is going to briefly describe the functionality of the program.
So as you can see, this is our applet that we used, and we basically only had two buttons, so that it'll be pretty simple to use. So as you can see, our radio is set at 20, which is the VOR station. And for demonstration purposes, we're just gonna test it out to see if we were not at the 20 degrees. So let's just say we're at 46 degrees, and we wanted to find our OBS radio. We would see when the needle would move. So as you can see, it's starting to get closer, and every dot symbolizes 2 degrees away from the radio. So as you can see, we are at 2, 4, 6 degrees away from what we're intended to be at. And as we get closer, we can see that after a while, we will hit the middle mark, which is the intended radio that we're supposed to go. And likewise, if we are below 20 degrees, it would show that these are negative, and this would be a negative 8 degrees away from what we are intended, which is, like we said, 20 degrees. And if it goes past the 8-degree mark, it would start to go offside, which indicates that we are very far away or not yet close to the VRO station radio. And as you can see, we are from, which it means that we're away from the VRO station. But as we go to other radios, you can see that as you see, it jumps to 2 after it hits a certain degree. And if there are no degree marks, it means that, or if there are no to and from marks, it means that we're either directly on top of the VR station, or if we are beamed, which is 9 degrees from either side of the VR station. So this radio means that we have hit a bad signal, and that one of the test cases of which you mentioned is happening. And if we wanted to get from Honolulu to LLC without going off course, we simply type in the LLC course Morse code over here, and it will give us the VRO station radio as well. And we input it into this constructor, and then all we have to do was match it up with the degrees that we find, and we'll be on our way.
Just to clarify things, the constructor here, this is going to be in Morse code. It translates it for us. For testing purposes, we just made the Morse code ABC just to make sure it printed correctly. This black borderline, it didn't show up in our PC when we coded it, but for some reason it only shows up in Macs. So that we couldn't find out how to solve it. But other than that, our program works perfectly fine and we're all set. Thank you.